Welcome to Platelets in Action. In this video, we will learn what happens when platelets become activated. Throughout this video, we will discuss the following take-home points. Activated platelets change shape. This shape change exposes and changes the shape of the platelet receptors GP2B3A and GP1B95. Activated platelets undergo adhesion, aggregation, and secretion. Let's begin with a group of platelets. When platelets get acted upon by an agonist, they undergo a shape change, known as activation. Activated platelets become sticky. Therefore, when they approach endothelial surfaces, they approach the surface and bind in a process known as adhesion. Once bound to the endothelial surface, platelets encounter strong agonists like collagen and thrombin that cause them to release the contents of their alpha and delta granules in a process known as secretion. During secretion, platelets release adhesive proteins and agonists which stimulate additional platelets to adhere to the endothelial surface and to each other in a process known as aggregation. The simple step of activation leading to adhesion, secretion, and aggregation is the primary work of all platelets. Let's more closely examine the underlying processes involved in platelet activation. Let's start with a group of unactivated platelets and allow them to undergo activation. Activation is simply a process in which shape change occurs. This shape change exposes the platelet receptor glycoprotein 2B3A or GP2B3A. GP2B3A is also more formally known as integrin alpha 2 beta 3. GP2B3A is a target of potent antiplatelet agents like epcizumab, eptifibatide, and tirofiban. The significance of the exposure and shape change of GP2B3A is that it allows platelets to recognize and bind fibrinogen and fibrin, which will become important in platelet aggregation. A second effect of activation-induced shape change is that it also exposes and changes the shape of an important receptor called the glycoprotein 1B95 complex, also known as GP1B95. This receptor allows the platelet to bind to von Willebrand factor on the endothelial surface. This interaction of GP1B95 with von Willebrand factor will become important when we discuss platelet adhesion. Now that we've understood the conformational changes that activate GP2B3A and 1B95, let's discuss the details of platelet adhesion. Let's start with a set of activated platelets that have changed the conformational shape of the receptor GP1B95. Let's also add a make-believe endothelial surface in the shape of a line. On our endothelial surface, high shear forces, such as those that occur during endothelial injury, expose the multimers of von Willebrand factor. GP1B95 recognizes von Willebrand factor and binds it. By binding von Willebrand factor, the process of adhesion is complete. Next, let's examine the mechanisms of platelet aggregation. Let's start again with a group of activated platelets. Remember that a key feature of activated platelets is the exposure and conformational change that activates the GP2B3A receptor. GP2B3A recognizes and binds to fibrinogen. GP2B3A also recognizes and binds von Willebrand factor. This affinity for fibrinogen, von Willebrand factor, and fibronectin, not pictured, allows other platelets with the activated GP2B3A receptor to also bind fibrinogen and von Willebrand factor in the process we know is platelet aggregation. Finally, we turn our attention to the process of secretion. Let's start this discussion with another set of activated platelets. Activated platelets are stimulated by strong agonists to release the contents of their alpha and dense granules. Dense granules release agonists that enhance platelet activation, including adenosine diphosphate, or ADP, and serotonin. Alpha granules release proteins that enhance adhesion, including von Willebrand factor and fibrinogen. As we discussed earlier, these proteins better help platelets to stick to each other. From what we have discussed, we have the following summary points. Activated platelets change shape. The shape change exposes and changes the shape of the platelet receptors GP2B3A and GP1B95. Activated platelets undergo adhesion, aggregation, and secretion. This ends the video, Platelets in Action. Ready, set, activate. We now have a deeper understanding of what platelets do when they are activated.